Alright, number 6. Here we have it. Remember how you can write secant using either sine or cosine? Remember what happens when you add pi? I like to bring the negative to the numerator. You totally don't have to, though. Every one of my steps has like some logic behind it that will help me get to the final answer. Each time I do something, I try to get closer and closer before I finally try to get the right answer. Just using the logic. Come on, chair. Number 7. Remember, anytime we have a minus theta, we always rewrite it. Remember how you can write cosecant as either sine or cosine? Remember how you find sine of negative theta? Remember what happens when you add pi? And I hope you all get this. Let me take some questions here. Okay. And finally, number 8. Again, I'll unfreeze here in a second. Alright, let me jump in here to number 8. Remember, anytime we have a minus theta, we always rewrite. Remember how you can write cotangent using cosine and sine? Remember what happens when you add or subtract 2 pi? And then remember how you find sine and cosine of the negative thetas. Let me stop here and see if there are questions on any number 1 through 8, and then I'm going to go to the last new concept for the semester. So no questions on any of this stuff? All right, let's go to the last piece. Page number 7, round 7, right here at the bottom. Page 7, round 7. So this is a topic, this is the last new topic of the semester. Call it Law of Sines and Law of Cosines. So last year, we did not cover this. The reason we're covering it this year is A, we're moving at a faster pace. Remember, we're trying to close the 7-week gap. But the other reason is we had a student graduated from Southwest last year, very good, qualified, capable student, went to U of H, passed AP Calculus when she was here. And in college they often make you take a placement exam to see which math class to put you in. This student was placed in pre-calculus because they failed that exam, and therefore had to A, take an extra class, and B, spend the extra $2,000. And part of the reason why she was placed in pre-calculus was because a lot of the concepts on the pre-calculus exam we never got to, because we're 7 weeks behind. So that's why this concept has now come into the curriculum, because this is something that will come up on every math placement exam you will take either next year or 2 years from now. So there's real money on the line here. Why do we have this law of sines, law of cosines? Well, before I tell you, let me take you on a stroll down memory lane. So let's draw a triangle here, call it A, B, C. And this is angle A. This is angle C, big C, like a big uppercase letter. This is angle B. And there are some interesting things we know right off the bat. So the first thing we know right away is that the angles sum to 180 degrees. The second thing we know is that angles are written with uppercase letters. Right. The next thing I know is that this is side A, side B, side C. And I know a few things about sides. The first thing I know is that sides are written with lowercase letters. Number 4 is that the side is across from the corresponding angle. Side A is across from angle A. Side B is across from angle B. Excuse me 1 second. So I know that sides are across from the corresponding angle. And the last piece, number 5, is the biggest side is across from the biggest angle. Biggest side across from biggest angle. These are the 5 really important basic facts about triangles. Before we go on, let me see if there are any questions on this. Nope. Okay. So the law of sines and law of cosines are really helpful because not all triangles in the real world are right angles. And therefore, if we didn't have these laws, we would not be able to use sine and cosine to identify lengths of sides. But these 2 laws, which I'll show you what they are in a second, just formulae, allow us to, for example, calculate how big side B is if we know 2 angles and another side. That's what this is helpful. And there are a lot of good application problems that you'll see in your winter break packet. Before we get there, what are these formulas? Formulas are the following. Law of sines says A over sine of angle A. Side A divided by sine of angle A equals B divided by sine of B, which equals C divided by sine of BC. In other words, the ratio of side length divided by sine of the corresponding angle, this ratio is equal for all side angle pairs. That's what we're saying. We also have the law of cosines. Which says c squared equals a squared plus b squared. That's Pythagorean theorem. But then because this is not a right triangle, we need to subtract 2 times a times b times cosine of c. C is the angle. A and b are this C, A, B are all sides. Okay. So let's sort of understand why and how to use these formulas. So to do that, we're going to use problem number 2 from round 7 on page 7. Problem 2. So it says we got triangle DEF. DEF. And they tell me that angle D is 62.3 degrees. Angle E is 28.7 degrees. And angle F, well, they don't give us that. But they tell us that side F, which is right here, is 12.1. This is side D. This is side E. We don't know what those are. Well, to find this angle, there are some people in the room who can already know how to find this angle. If you are comfortable with finding that, go for it. The way I would find it is by doing the following. Please let me know if there are questions of what I'm doing right now. Any questions here? Okay. So now my task is to find D and E. The issue is the following. I don't know whether to use law of sines or law of cosines. And maybe you all are equally wondering. So here's how I know. So if you look at the formula again, law of cosines has 4 things that are unknown. All 3 sides and 1 angle. In order to use law of cosines, you must know 3 out of those 4 things. With any equation, you can only have 1 variable for you to solve it effectively. So law of cosines is used when, well, maybe you have all 3 sides and you want to find that angle. That's